law of cosines is used for solving oblique, meaning non-right, oblique triangles, okay? Given side angle side or side. Okay? So we've already solved with law of sines. You're solving with, you have ASA, you have AAS, and then you have the ambiguous case of SSA. So law of sines, LOS, law of cosines you use if you have that kind of relationship. Okay? And maybe remember, so it doesn't mean they're congruent, but it means you have a side and an angle in between that side and another side, or three sides, and you can solve the triangles. And so what law of cosines looks like? It looks a lot like the Pythagorean theorem. A squared plus A squared equals B squared plus C squared. But because it's an oblique triangle, let me draw an oblique triangle. Oblique. That looks kind of, whoa. Does that make a triangle? Ooh! I love that too. Okay. So because it's an oblique triangle, if it were just A squared plus B squared equals C squared, then you would just use the Pythagorean theorem, right? But because it's a oblique triangle, I think they prove this, you can look at the proof in the book, using the law of sines, but then you have to add or subtract something, depending on whether this angle is obtuse or whether that angle is acute, right? So if this is an angle that's less than 90, then you're going to have to subtract something. If this is an angle that's more than 90, then you're going to have to add something, right? And that thing that you add or subtract comes out of the law of sines, and it comes out to be 2AB, nope, that's wrong, 2BC cosine of A, angle A. All right, and that's called the law of cosines. How many of you seen that before? I hope yes, you've seen it before. Okay, so the one thing to be aware of, let's call this let's call this B, and let's call this C, right? And this would be little c, and this would be little b. It doesn't matter where the letters go, okay? But what matters is the side that you're trying to solve for, like over here, that would be the thing that would go by itself, okay? And the two sides that you know, those would be the sides that you know, and the angle is the angle that is either across from this side or between these two angles, okay? So A is over here, B and C, and then B and C surround angle A. So if I want to do law of cosines for this angle over here, you could use the same formula, but it would look like B squared equals what? If I did for this angle on this side. If I wanted to find this side, how would I write that? B squared equals what? A squared plus the other side C squared minus 2, these two things go together, the A and the C, and the cosine of the angle opposite side B, which would be B. And likewise, if you had C squared, it would look different and so on. But all you have to know is that this is the side opposite this angle, and these are the two sides surrounding that angle, or which are not this side. Okay, so that's kind of the way to remember it. I wouldn't try to memorize 3 different formulas because it's just the same formula, you know. And then the other thing is you can write this in a nice form when you're trying to find an angle. So this, if you solve this and you do a little bit of algebra, you would get that angle A is equal to B squared plus C squared minus A squared, or sorry, not angle A, cosine of A is equal to B squared minus C squared over 2BC. So if you just want to find an angle, it's kind of quicker to just use this formula than to plug everything in and then subtract these two things and then make a mistake and divide that, okay? So So if you just want to find an angle, it's better to use this. Even better than that, you could say that A is equal to the inverse cosine of B squared plus C squared minus A squared over 2BC. 2BC. And so this is a really quick formula. If you want to find an angle, all you have to do is take the inverse cosine of this squared plus this squared minus this squared over this 2BC. Right? Because that's basically what this says. Cosine of this is equal to this, so the inverse cosine of this is equal to angle A. Okay? And so that's a nice, quick, easy formula. So you ready to do some examples? Yes? Okay. So I found a new resource, so I don't have to do the exact examples out of the book. I have other examples now. And sometimes I make up my own examples, but then I have to do all the math, which I don't want to do. So given a triangle, so these are a little bit different than the ones you'll see in your book. Given a triangle with sides with sides 5, 8, and 7. 5, 8, and 7. Oh, and they even give you numbers. A equals 5, B equals 8, and C equals 7. Solve the triangle. Find all three angles. Find all three angles. Okay? So this is a case in which you have side, side, side. So out of those formulas, I want to find an angle, right? So I probably want to do that last formula that I just gave you. And so all I have to do, so I think too it's helpful to draw a picture of it, okay? No matter what you do, it doesn't have to be right, but just so you can rethink where things are. So let's call this A, this B, this C. It doesn't matter how you label it as long as you're consistent. So this is going to be 5, right? B would be over here, we'll call that 8, and C would be 7, even though it's probably not to scale. But another thing that's important to remember when you're doing these things, when you're kind of checking yourself to see if you're getting it right or wrong, is that the biggest side is opposite. You don't have to draw it to scale when you're doing it, but the biggest side should be opposite the biggest angle from geometry. And the biggest angle, then the smallest side should be opposite the smallest angle. So does it look like I kind of have this to scale? And it's just because here I call this side 5, this looks like the biggest side, and this looks a little shorter. So I kind of drew it so it kind of looks like it's to scale, so when I'm finding angles, I go, wait, that doesn't look right. You know, maybe I did something wrong. Something like that. All right, so then what I'm going to do, it doesn't matter which one you pick. So I'm going to decide to go for angle A, okay? So for angle A, I'm going to take the inverse cosine, okay? The angle A is equal to the inverse cosine. So if this is angle A, it's these two sides by themselves first, okay? So it's the two sides surrounding the angle first. So it would be 8 squared plus 7 squared minus the side that's opposite angle A. So that's the thing that's kind of the lonely guy over there. Over, yes, that's right.
Why is it squared?
Because that's the formula. See?
Write the formula.
I did, right there. B squared plus C squared minus A squared over 2.
Oh, great.
All right? Okay?
Wait,
So,
what's it?
what?
Can you leave that up? What's the inverse?
Oh. Wait, I'll leave that up for a second.
Yeah.
Because then it'll mess things up. All right. So I'm just plugging in here, and then these two sides, the sides surrounding the angle, go underneath. All right. So that's times 2. There's a 2 there, and times B and C, which are B and C, right? Times 7 times 8, and then I just plug that chunk into my calculator. All in one shot, and it's best to do it like that because then you don't have any rounding errors and stuff like that. So I'm going to take my calculator now, and I'm going to make sure that I am in mode degrees. I am, good. And then I'm going to go inverse cosine, second cos of, I know what a squared is, so I'm not going to write a squared. 64 plus 49 minus 25. Okay, and then you want to divide that. I think I might need two sets of parentheses here. Do I?
Yeah.
Yeah. So I think I need to go back here. See, so I'm going to insert a parentheses. Okay. Did I do that? In parentheses. There, and then I want to close that parenthesis to indicate that I'm dividing the whole thing. Okay. Close that parentheses, and then divide that by, maybe you could do that 56 times 2. What's that? 112? Divide it by 112. And then you're going to close the parentheses for the inverse cosine. So I've already closed this one. And then I get that angle is 38.2. Okay? So that angle is about, so A is about, what did I say? 38.2? Is about 38.2 degrees. And then you want to find all three angles. So now, yes, sir.
From there, could you use law of sines?
Yes. Now you could use law of sines. However, you have to be kind of careful, because if you did, you can't really, okay? Because you would have an ambiguous case, even though, because you have an angle side, even though you have three sides and an angle, it's not really ambiguous. But if this is an obtuse angle, you wouldn't know it. You understand what I'm saying? Yeah, because if if this did turn out to be an obtuse angle, which it's not in this case, then you would have to take the supplement of that angle. And you're not, just by the way the triangle looks, I can't tell if this is an obtuse angle or an acute angle. You understand what I'm saying?
Should you just find angle B first?
You should find angle B first using law of cosine. Or, yeah, that's what I would do. Okay? So let's find, so then angle B, just to set it up, I'm not going to do the calculator again. So angle B would be the inverse cosine of, who can tell me what that would be? What would angle B be? What goes there?
Squared
Good.
plus 7. No.
5, yes.
Plus 7
5 squared
minus 8.
plus 7 squared minus 8 squared over 2 times 5 times 2 times. This part isn't squared on the bottom, right? And then if I do that on my calculator, I did this one. Did I solve? I solved for the wrong angle. What do I get? I guess I do have to do this. I end up getting that angle B is about 81.8 degrees. Okay? B is about 81.8 degrees. So it turns out that this is not an obtuse angle. But if it were, you wouldn't know it if you used the law of sines. Because if you said sine of this is to this, a sine of this is to this, then you're going to get an acute angle. Okay? And you would have to take the supplement of that if it were obtuse. But you don't know. Like law of cosines, there's no ambiguous case. Okay? So there's just an answer, which is nice about. Then you could go ahead and use law of, you don't need to use law of sines. Look at how you find this angle. That's just, you add them up, right? You subtract from 180. So 180 minus 38.2 minus 81.8 is equal to 60. Is that right? 60 degrees. So this angle right here is exactly. Okay? Yes? So that's a side problem. Maybe we should do a side angle side problem with the word problem instead, because I don't want to do the word problem. It's too long. So let's just go right to a bearing problem. Okay? Can we go right to a bearing problem? My skateboard had a bearing problem the other day, but I got it fixed. Okay. Bearing. It was wasn't rolling very well, so I got some new bearings, you know. That's not, so here's a bearing problem. I'm going to type this in because it's a long problem and I want to. This is a good bearing problem, and it deals with the law of cosines. And they love to give you bearing problems when they do law of cosines. And this one's not in your book, so you should pay attention. So you need to learn to draw pictures of these things to help you solve them. So a port is 50 miles due north of a lighthouse. So if this is the lighthouse, here's the lighthouse. The port is straight up here. So you're gonna go like this, and you're not gonna do it in white, and in a different color. You're gonna draw, make it a solid line. And you're gonna go like this. I don't want dotted line. Let's make solid line. Solid line. Solid line. Okay. So I'm gonna go like this. And then so here's the port, okay? And then it says the ship is 30 miles at a bearing north, 37 degrees east. So what does that mean? The ship is at a bearing north, 37 degrees east from a lighthouse. All right. Right, so it's going this way at an angle of 37 degrees. So you need to learn how to kind of draw those pictures. So over here, this is so this angle right here is 37 degrees. That should be in degrees, right? Degrees.
And if it's acute, it's a minus or plus.
You don't have to worry about that. There is no plus or, yeah. So, and this is at 30, and this is 50. And here's the ship, right? Here's the ship over here. So lighthouse, ship, port. So what you're trying to find is the distance, this distance from here to here, right? That's what it says. How far is it from the ship to port, right? So you want to find that. So do you see that this is a side angle side triangle? Right angle side? So what am I going to use? Law of sines or law of cosines? Law of cosines. And in this case, you don't want to use the one that says where you're not finding an angle, you're finding a side, right? So you're going to use that first formula. So if I call this side C, I can say that C squared equals A squared plus B squared minus 2AB cosine of C, right? And so then I'm just going to plug what?
31.6.
Hey, slow down there. Henry knows the answer already. So C, so you leave C squared by itself. A squared is, we'll just call that side 50 squared, plus, I want to show you a mistake that lots of people make. 30 squared minus 2 times 50 times 30 times the cosine of what? 37, just like that. Now, what you can't do, that people do all the time, okay, is they put this all together. They say, oh, 50 squared plus 30 squared minus 2 times 50 times 30, and then I'm going to multiply that by the cosine of 37. You can't do that, okay? Because you do, remember order of operations? Multiplying and divide comes before add and subtract. Please excuse my dear Aunt Sally, right? So you have to do this part kind of separately from this part. Okay, otherwise you're going to get a wrong answer. And you say, my calculator doesn't work, it's broken, can you fix it for me? It's because you're not following the correct order of operations. Now if you have a if you have a graphing calculator, I think it will automatically take care of that for you, so you don't have to worry about it. Let's just see. So if I go 50 squared, which I know is 2500, 2500, my plus 900, which is 30 squared. I think most calculators will do the order of operations for you, but you have to be careful because minus 2, what's that, 1500? 1500, 2 times 1500 times the cosine of, you don't even need a cosine of 37. Did I mess up? Did I mess up, Henry?
No, you're good.
Okay. Right, I'm just wondering about that. And then you hit that. So that is C squared. And then I go second square root, which is above x squared. Second answer, because I need to take the square root of that. Okay, like that. And then I get out that it is, Henry was right, it is, whoa, where'd that go? That it is about 31.69 miles. 31.69 miles to the ship. Now at this point, if you wanted to find this angle and this angle, could you use law of sines? You could again use law of sines if you wanted to find these angles. But again, you have to be careful because if this is an obtuse angle, law of sines is going to probably give you an acute angle, right? So you want to use a lot of cosines again. If they did ask you this angle or this angle, you would want to use a lot of cosines. Okay? So you understand how to use a lot of cosines? Okay. One last thing. There's Heron's formula. It's easy. Okay? Heron's formula. Ready? Have you ever heard of Heron's formula? Okay. And they always put it here because it's derived from the law of sines and cosines. And Heron's formula is a nice thing. Heron's formula. Hold on, I'm recording. Why? To find areas, to find the area of any triangle, any oblique triangle, oblique tri, given three sides. And it just looks like this. Area is equal to the square root of S times S minus A plus S times S. Is it times or plus? I gotta remember. I don't remember. Oh, it's. I better make sure I wrote that down. I'm pretty sure it's. I thought it was plus. Maybe it's times. Hold on a second. Oh, I better pause. I messed up. It is times. That's the way I had it in my notes. Okay? Times S minus B times S minus C. Okay? And so A, B, and C. A, B, and C are just the three sides. Are the sides, lengths of the sides, length of sides. And S is equal to 1/2 of the perimeter. That's all it is. Perimeter, which is equal to A plus B plus C divided by 2. Alright? So they came up with that through, you could derive it relatively easily through the law of sines and cosines. So say, for example, I have a truck. What?
Would that work with like a equilateral?
Would it work? Yes, it would work with an equilateral triangle.
But like a right triangle?
Right triangle? It would work with a right triangle. Yeah, but what do you do with a right triangle? All you have to do is base times height divided by 2, right? Right hand side divided by 2. So say, for example, I'm going to make up one here. Whoops. I make up one. So let's draw a triangle. Draw a triangle. Why is it not? Oh, because I'm in white. Let's draw a triangle here. And let's say that this side over here is 8, this is 9, this is 7 or something. And they say find the area. Find the area. And you could go and find the height, and then you multiply base times height and you have to do something, but this is just kind of a shorter method for doing that. So S, in this case, is going to be 8 plus 9 plus 7. Should have made it come out nice and neat, but it doesn't. Divided by 2. So it's at 17 plus 7. Oh, it does come out neat. Is that 12? Yes. 12. So that means that the area is equal to the square root of 12 times s minus a. So 12 minus 8. Doesn't matter what you call a, what you call b. So that's going to be 4. 12 minus 8 times 12 minus 9 times 12 minus 7. Okay? Which in this case, that would be equal to the square root of 12 times 4 times 3 times 5, which is the square root of 2060, 700. Did I do that? 720? Is that right? Square root of 720. Could you do that on your calculator for me? 20. So that the area of that triangle is about equal to 26.8. So variance formula is just a quick way to find the area of a triangle and give it 3 sides. And that's all she wrote, folks.
Sweet.
Okay? The end.